I'd like to show a project that takes serverless, which is a framework to build and maintain web, mobile, and IoT applications running on AWS Lambda, an API gateway, along with GraphQL. GraphQL is a data query language developed and used by Facebook, and it's implemented in a way that can consolidate a number of endpoints into a single endpoint. This would replace a REST-style architecture, and that you send queries which are defined as strings to a back-end app server that processes the query, fetching data from databases or other endpoints and assembling them into a structure that you've requested. Here's an example GraphQL query. Notice that it looks like JSON. The server responds with the JSON that was requested. I have implemented a project which installs GraphQL into a serverless Lambda function and provides a single endpoint to allow you to query data on DynamoDB. To install it, run serverless project install serverless GraphQL blog. Once the project's installed, you have a fully working serverless project. Inside, there's a blog component, a resource module, and a GraphQL function. This is a Lambda function that implements the GraphQL application server and which will communicate with DynamoDB or any other data sources that house your data. This is the endpoint for resource GraphQL. It accepts a single query request parameter and passes that to our handler. Our handler runs a function called runGraphQL. What this does is call GraphQL with the schema that we've defined, and we'll look at it in a moment, and the query that's been sent as a string. This is a GraphQL query. It computes it, and then it returns the result. GraphQL responds to promises, and this is what the then responds to. The schema is normal GraphQL schema. GraphQL allows you to define strict types. So in this case, I have an author, and I've defined the fields ID and name with the type of GraphQL string. It is then used in the queries below. It is also used as a subtype. Here in the GraphQL query for author, I can pass in an ID. Once GraphQL has that, it can then execute this resolve function, which in this case has a getAuthor function, which will then query DynamoDB and return us the data for that author. Here I have a set of queries defined, and here I have mutations. Mutations are writes that go through GraphQL. So this is a write implemented to create a blog post with these defined arguments, and again here's the resolve function that's executed with those arguments. This is passed to the GraphQL schema and returned. And you can read more about this on graphql.org. Finally, the Dynamo file in this project structure contains the logic required to communicate with Dynamo tables that store this data. There are 3 tables that are created based on your project name, the post, and stage. And there are functions that correspond with the different requests. Here is a Dynamo query to scan the table and return the items for the posts. Here we're specifying that these are the attribute types that we want to return. This should ultimately match what your definition in schema is for your GraphQL post. Notice that we return a promise, as that is how GraphQL operates. It needs a promise or data returned in the resolve function. Here I'll use curl against a deployed development resource endpoint that I have for this GraphQL project. Here I have a query that is valid GraphQL. This is requesting the posts with an ID and an author name to be returned. Here we get that data structure back. GraphQL executed this query, provided us the ID and the name and the author object with the name of each author and each post. Here is an array of posts. I mentioned that a mutation was a way to write data to GraphQL. Here we've defined the new post that we want to create. This could be done client side, or it could be done from a command line like so. Notice that I'm only passing 9 characters, and we have a validation on our schema that limits us to, that requires us to pass a minimum of 10 and a maximum of 30 as we're creating this post. In this case, we receive an error from GraphQL. This was defined using the GraphQL limited string type, which is available in the GraphQL custom types npm package. You can examine the source to see how to generate your own custom types and your own errors. Finally, if we correct the title to have the proper number of characters, this mutation is also followed up by a GraphQL query. So when we execute this mutation in GraphQL, we've defined that we want to receive the ID and title back. Executing that query, we get the new post and we get its new title. My final demo is showing the tool Graphical, which was put out by Facebook and allows you to query your data in a visual medium. Here I've got my endpoint that implements my GraphQL server, and instead of using curl, I can use this query panel to query the data and receive my response nicely formatted. What's neat about GraphQL is that if I choose a different shape for my data, all I have to do is send the appropriate query, and then I'm only presented with the data I've requested.